Hi calculus fans, it's Mrs. Willenbrock here. Welcome to Unit 6. We have Unit 6 and Unit 7 to go, so we are getting very close to the finish line. Unit 6 we are going to talk about some other fun functions and how to work with them in terms of derivatives and integrals. And one of our favorite functions that we all love is the natural log function. And so let's take a look at how he works for the derivative. The natural log rule for taking a derivative is actually really simple. And it's right here. So when we take the derivative of the natural log of x, the derivative is going to be 1 over x. Piece of cake. As long as x is greater than 0, because if x itself is not greater than 0, then you actually can't use the natural log function. That means we're not within the domain of a natural log. If we have the natural log of another function, then we use the u notation to represent u as a function. Well, the derivative of the natural log of a function is 1 over the function times the derivative of the function. And that's just, we should be used to this by now, anytime we have a function of a function and we're hitting it with a derivative, there's typically a chain rule aspect to it. Okay. If this happens to be the absolute value of a function, because we want to make sure that it's something that the natural log will work with. So we want to make sure that the function is not less than 0, and we're going to assume that the function isn't, so the function can't be 0, and we want to make sure that we want to be able to think about the function values that are greater than 0. The nice thing is having that absolute value there kind of doesn't really affect the derivative. We take the natural log of the absolute value of u, it's still 1 over u times the derivative of u. Right. So just if you happen to see that combination. All right, so we're going to look at a few examples together. I'm going to leave some of these for you to do as practice and then pull up the key and check your work, right? Because the idea is you do as much as you need to do to make sure that you can take this derivative whenever you're asked. Okay. So the natural log of a quantity, a function, x squared minus 3, my derivative would be 1 over x squared minus 3 times the derivative of x squared minus 3, which is 2x. And, if for whatever reason, it might be nice to make a little cleaner version of that, and so 2x over x squared minus 3, but leaving it as 1 over x squared minus 3 times 2x, also appropriate. Okay. And so maybe try number 2 and see what you get. Okay, ultimately, you're going to look at something like that. Okay? If we have the natural log of something to a power, you actually can do a couple different things with that. And we're going to talk in more detail about this on the next page. But one option is we apply our natural log derivative chain rule and we say, well, the derivative would be 1 over x to the negative 1/2 times the derivative of x to the 1/2, which would be 1/2 x to the negative 1/2. And so then if we kind of clean this up a little bit, that's going to be equivalent to 1 over 2x. couple things have to happen to make that happen. I have to understand how the half works. I have to understand how x to the negative 1/2 can get rewritten. And I have to understand how x to the 1/2 times x to the 1/2 makes x using the exponent rules. However, natural log functions have certain properties. And one of the ones that you might remember, or not, is if you have the natural log of, for example, something like 4 squared, that can also be rewritten as 2 times the natural log of 4. Right? That these are equal expressions, and if you check that with your calculator, you'll see if you take the natural log of the quantity 4 squared, and if you take 2 times the natural log of 4, you get the same result. Okay, so that the natural log of a to the b equals b times natural log of a. So, given something like the natural log of x to the 1/2, you may decide, I think I'm going to rewrite that as 1/2 times the natural log of x. Now, this is where it gets a little tricky because you're like, you took the derivative. No, I didn't take the derivative there. I just rewrote it because of a log property. And now if I take the derivative, I have that constant, and then the derivative of natural log of x is 1 over x. So you can see I get the exact same 1 over 2x. Is one better than the other? Better is relative. It's what you understand. So, you know, if you're fairly comfortable rewriting log expressions using properties, sometimes that will then make a simpler expression to take the derivative of, and you'll get to a simplified answer a little more quickly. However, if you're like, man, I can't, let me just attack the problem using new knowledge. So the derivative of the natural log of a function is 1 over that function times the derivative of that function. Truly, if this was a free response question, this kind of answer wouldn't be wrong. It's just not your prettiest answer. If we're in a multiple choice situation, though, you may have to figure out that this is the actual answer they're looking for. So you're going to have to apply some other mathematics, potentially, either in understanding how to simplify this expression to get to 1 over 2x, or understanding how you can rewrite the natural log of x to the 1/2 as 1/2 natural log of x, and then take the derivative. Now, as you look at this front page, you can see all my other rules are in play here. I've got a product rule, which is what this is too. I'm going to have to use the product rule to write that derivative. Okay. I have a couple quotient rules. I have a train, not a train, it's a chain. I have a chain rule. And I have trig. Okay. So we've got a lot of different rules here to practice and check answers against. Okay. I'm going to recommend at this point you stop and work through the remaining questions 4 through 12 and check your answers to make sure that you're comfortable with the basics of taking the derivative using a natural log. Okay. Basic idea, when you're taking the derivative of the natural log part, for example, if I'm doing number 10, the derivative of the natural log of a cosine, okay, where this is kind of acting as your u, your derivative will be 1 over the cosine times the derivative of cosine. And so an alternate answer to this would be something like that. We've got lots of different things that can come into play in terms of simplifying to affect our answers. So we're always going to have to be sort of looking a couple steps down the road and think, okay, if I do this, I get this answer. And if you're looking at a multiple choice set, you say, okay, I don't see that. What else might I do to rewrite the problem? Okay. Time for you to practice. See what you can do on 4 through 12.